What's up, guys? Let's talk about objects and programming. So, real quick, what exactly are objects? Well, one way to think about this in regards to programming is that objects are really just kind of like a template representation of something in real life, but in code. Okay? So, you guys are on this video. I'm assuming you guys already know basic variables like, oh, this is a string variable. What is an integer variable? Blah, 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 blah. So you can represent numbers, words, trues and falses, et cetera, in programming already based off of primitive data types in programming languages. But what if I wanted to represent something in real life in our program? So I don't know, I want to represent a 2017 Ford Mustang in code. There is no Mustang variable, okay? You're not going to get a predefined Mustang variable from your programming language. So if we want to be able to utilize that and create that in our software, we have to create it ourselves via an object. So that's one way to look at objects, just so you guys understand off the bat. But objects are used in many programming languages, but most importantly, in object-oriented programming languages. And what is an object-oriented programming language, you might ask? An object-oriented programming language.
An object-oriented programming language is a programming paradigm based on the concept of objects which contain data.
So really, guys, it's really just a style of programming languages that revolve around data and this concept of objects, okay? And yeah, just object-oriented programming is usually denoted by all the cool kids as OOP. So now that we've got all that out the way, let's actually kind of explain one of the biggest parts of objects, which is inheritance. So if I have objects in my program, and let's say maybe I want to use an object that is kind of like going to be very similar to all other objects, and then maybe those other objects might share the same similarities, but also might have differences, okay? Now, I know that probably didn't make any sense just off the bat, but just bear with me. So let's take something generic that is in the world, like an animal. I have an animal, and what do animals do? What do all animals have in common? Animals eat. Animals sleep. Animals breathe. All right. Now, what about specific animals? So, I don't know, like a dog. Are dogs the same as all animals? No. But dogs are animals. So one could assume that a dog also eats. One also sleeps. And dogs also breathe, right? Now, what's something specific that a dog does that other animals don't do? Bark. Yes, that's right. Dogs bark. Okay? Do all animals bark? No. But all animals do eat, sleep, and breathe. And a dog is an animal. So a dog eats, sleeps, and breathes. But a dog also barks, which makes it different from every other animal. Now let's take another animal for an example. So cat. Cats are animals, right? So they also eat. They also sleep. And they also breathe. Cats also have something specific that they do, right? Meow. Okay. Do dogs meow? No. Do cats bark? Nope. But dogs bark. Yep. And cats do indeed meow. And since a dog is also an animal, and a cat is an animal as well, cat eats, sleeps, and breathes. Dog eats, sleeps, and breathes. All animals eat, sleep, and breathe. So inheritance is the idea of basically having something that is a parent and then giving its properties to its children. So dog is going to be a child of animal, and cat is also going to be a child of animal. However, cat is not a child of dog. Dog is not a child of cat, which is why a cat cannot bark and a dog cannot meow. So the key thing to actually learn about all this, fellas, is that if your parent is giving its, in this case, we could say this is a function. These are functions: eat function, sleep function, breathe function. Well, if the dog inherits from animal, the dog is going to eat the exact same way, sleep the exact same way, breathe the exact same way. And if the cat is inheriting all the properties and functions, in this case, of animal, a cat's going to be able to call that sleep function, that eat function, and that breathe function, right? Now, these bark and meow functions they're also, or rather they are functions as well. We can consider that. And a cat does not have access to this bark function in the dog, and the dog does not have access to this meow function in the cat, okay? So just because they share the same parent right here doesn't mean that they're the same. The only thing that they have in common is the fact that they all eat, sleep, and breathe together, okay? Now, the reason for you'd want to use this is many reasons, but without getting philosophical here about it, you never really want to repeat code, okay? Never want to repeat yourself. So if we have something like this, which actually comes up very, very often, so like if we were thinking about 2017 Ford Mustang, well, a 2017 Ford Mustang is not the same as a 2018 Ford Mustang, and that's not the same as a 2019 Ford Mustang. So maybe the Mustang itself would be a parent object, and then each year would be its own child. And hey, maybe Mustang is a Ford, right? Maybe the Mustang object has a parent object that's a Ford. Did I just blow your mind? So I hope that helped. I am actually going to be explaining how to actually utilize this briefly in another video to make it easier for you guys. I'm going to use Java because Java is an object-oriented programming language. So if you want to watch that, I'm going to put a link for that somewhere on the right-hand side of this video, and you can check that out later.